So this is what we were doing for the single stub batching case. Are you there? We lost connection. Okay, are you there? Yes, there is some network issues. Anyway, whatever I had said, I have written. Can you just read what I have written? Everything I told you, I also written on the board. Just see what I have written. So this was basically the concept of single stub batching. Okay, is it better now? Is it better now? Okay, fine. If there is a problem, just write on the chat. So this was the basic concept of single stub batching. What were we doing? We have to identify the point where the admittance is 1 plus JB. Okay, and we need to introduce a stub whose admittance is minus JB at that point. So the overall admittance becomes 1 plus JB minus JB, that is 1. And we have got the match. Now see what the disadvantage. Two of you just said. If the load is changed, the insertion point must be changed. Yes, that is true. Very true. Location has to be fixed at one end of a single stub. This is not quite true. Actually, you know what, Kritika? This is exactly the disadvantage. Now, see, going through both of your points, the first thing we need to do for single stub batching is we need to identify this L where y in of L is 1 plus j, right? Now, on that point, we need to put our stub. If you put our stub any other point, we will not get the match, right? So it may not be possible for all the lines to put a stub at any given point. Okay. So this is the big disadvantage of single stub batching, right? If the point 1 plus JB is somewhere where there is some joint or something, we just cannot put a stub. So it is difficult to match. Is this clear? Disadvantage is that we cannot put the stub practically in any position we like. Is it okay? Any questions? Okay. So this disadvantage is countered with double stub, which is the topic of today's class. Okay, great. Right. So for double stub matching, what we are doing? For double stub matching, instead of one stub, as the name suggests, instead of one stub, we are putting two parallel stubs. Okay. And the difference is that, of course, we have two stubs. The difference is that this position is fixed. This position is the position of the stubs where we are putting the stubs, they are fixed. We cannot change them. The positions where we are putting the stubs is fixed. We cannot change them. What we are allowed to change? We are allowed to change the lengths of the stub. This length is L1 and this length is L2. Changing of L1 and L2 is allowed. But changing D1 and D2. D1 and D2 are fixed. Okay, we cannot change D1 and D2 in under any circumstances, but it is allowed to change L1 and L2. Okay, so we can set D1, D2 as per our convenience. Okay, so we do not have to put the stub anywhere. Wherever it is convenient to us for us put the stub, only there we can put. Okay, so disadvantage of the single stub matching is mitigated. However, double stub matching has its own disadvantage. What is that? Using double stub matching, it is not possible to match all impedance. You get my point? Using double stub matching, it is not possible to match all impedances. This problem is solved in triple stub matching, but triple stub matching is not impedance. Okay. So let us see this in detail. By the way, everyone, please go to this RF microwave characterization lab on the virtual lab. Okay, there log in and here go to this place. Okay, go to here, study of behavior of impedance matching for passive networks using Smith chart. Click here. Okay, you log in. Your ID and password. Okay, and we would be running this experiment, double stub matching. Okay, so please download it and we will. So do we have to match one stub, sir? Ritika, we are not matching the stub. We are matching the impedance. We are not matching these stubs. We are matching this ZL. Okay, that is our goal. But no, actually, you see, we can change the lengths of both stubs. That is allowed. What we cannot change is the position of the stubs on the transmission line. Okay. So please open this because we will be using this for the lab. Okay. And please give your feedback. It is mandatory. as I told you that impedance matching can be achieved by inserting two stubs in specific locations. Okay. And as I told, L stub 1 and L stub 2 we can change as per our own convenience. D stub 1 and D stub 2 are fixed. We cannot change them. Is it okay? As I told you, there are two design parameters for double stub meshing. The length of first stub line L1, L stub 1, and the length of second stub line L stub 2. L stub 1 is this, and L stub 2 is this. Okay? So this is how a double stub meshing circuit looks like. Is it okay? Now, in the double stub matching configuration, the stubs are inserted at predetermined locations. In this way, if the load impedance is changed, one has what Niloy had already said. If the load impedance is now changed for this configuration, we just have to change the lengths of the stub and it will get matched, provided the new load impedance is possible to match. Okay, given that. If we change the load impedance and it is possible to match the new load impedance, so what we need to do, we do simply change L stub 1 and L stub 2 and we can match it. Is it clear? And note a drawback. Certain range of load impedances cannot be matched. Okay? And 3 stubs are necessary to guarantee it, but 3 stubs cannot. So what it happens? What does it happen? So what are the functions of the 2 stubs? Let us focus on the first stub. Okay? What we are doing? Here is the load, D stub 1, L stub 1 and D stub 2. We need to adjust L stub 1 in such a way that the load admittance as seen here. Adjust L stub 1 such that this Y in is 1 plus JB. Pankaj has to wait. You get the point? We have to adjust this length of L stub 1 in such a way that the load admittance seen from this point. Load admittance seen from this point is in the form of 1 plus JB. Once we do it, we need to put the second stub whose admittance is minus JB and we have balanced it. Is this okay? This is the most critical aspect of double stub method. Is this concept okay? This will be such that, not such that, such that. Oh, sure. So we can change the length of L stub 1. This is allowed to be changed. This is fixed. This is fixed. Okay. So we have to adjust the length of L stub 1 in such a way so that the input admittance as seen from this point is in the form of 1 plus JB. Is it okay? We need to adjust L stub 1 in such a way so that the input admittance as seen from this point, this arrow, is in the form of 1 plus JB. Then what is next to be done? At that point, if we put a stub, second stub, of admittance minus JB, we have reached our goal. We have matched it. This is the basic principle of double stub matching. Is it okay, or you want anything to be? Okay, great. Exactly what I told. See, exactly what I told in the previous slide. They have done that. They have simply put the second stub and just read what they have written. Okay. So this is the basic principle. Right? Any questions so far from anyone? Okay, now look at this. Do you understand what is written in this slide? Especially one is the blue. Can anyone help me to explain what is written in this slide? Especially the thing that is written here, the blue one. What does this thing mean? What does this thing mean? Can anyone explain what does this thing mean? What is this blue circle on the Smith chart? What does the blue circle on the Smith chart signify? Exactly z equal to 1 circle. Absolutely right. But since we are exactly very good, very good. Actually, Rakesh, it is not impedance equal to 1. Ritika's answer is more accurate. It is R equal to 1. Okay. It is R equal to 1, not Z equal. So R equal to 1 circle. So, but since we are considering admittance, we take it as G equal to 1 circle. Okay. So, any point on this circle, it will have an admittance of J plus B1 or sorry 1 plus JB1 or 1 plus JB2 or 1 minus JB3 in this form, right? Any point on the blue circle will have its admittance in the form of either 1 plus JB or 1 minus JB. Is it right? Okay. On the circle, we have the required minus JB. Yes and no. Some part of your point is correct, but some part is not. On the circle, we have the admittance in the form of 1 plus JB, okay, not minus JB. And then if you put a stub of admittance minus JB, we get the match. Okay. So, what we need to do is, after putting the first stub and moving by the distance d stub 2 minus d stub 1, what I mean is this. Very difficult to draw. Okay. So D1 is here. We are putting an admittance and then we are moving. So we have to reach this point. This point must lie on the blue side. You understand? This point, the admittance of at, not of at, this point. Which point? This must lie on the leaf. Is it okay? Then what he said, we need to put a stub of admittance minus JB and we have matched our. Okay, any questions so far? Please open this because we will be using this right after the discussion. We will be using this. See, can anyone understand? If you have no doubts, then you will be able to understand this. Explain this slide. Who will explain this slide to me? Who will explain this slide to me then? Just anyone who wants to explain? What this slide say? If you can explain this slide, you are understood both single stem and double stem matching very well. What does it say? What does it say? Who can explain what is given in this slide? Anybody wants to try? Anybody wants to try? Okay, see. There are two different ways of reaching this 1 plus j. Okay. Fine, somebody has tried. Sir, for the first step, they are putting the stub at d stub 1 location and calculating the y from d stub 2. But do you know which one we are explaining? This one? And after that, they are putting the stub at d stub 2. Yes, that is for this one. So that is not bad. That's a good one. The first method is single stub. So in both ways we get the point 1 plus JB. In this way also, in this way also. In this way, we get 1 to 1 plus JB by varying this. Vary this. In the single stub case, we are reaching 1 plus JB by varying what? For single stub case, what thing we were varying? Exactly, very good. Varying this. So we need to change something. Yes, very good. So we need to change something. For single stub case, we are changing the D stub one. So we are getting the problem that you need to put the stub on a specific location, which may not be possible in. This problem was solved in double stub case where the location were fixed, but we could change the length of the stub in first step. Okay. So both ways we reach the same point 1 plus JB, and when we reach 1 plus JB, in both cases we need to do the second step. Second step for double stub matching, or the first step for single stub matching, and we get the match. Is it okay? Okay. Okay. This one is a bit tricky to understand. If one moves from the location of the second step back to the load, the circle of the allowed normalized admittances is mapped onto another circle, obtained by pivoting the original circle at the center of the. What does this mean? What does this mean? Just note this paragraph is very important. Note what is written in black. As you can see here, there are two circles. One circle here, one circle here. Okay? And this blank paragraph tells us the story of the two circles. What are these circles? This circle is familiar, right? This one, the blue circle we discussed. What is the other circle? Why it is coming? That is told here. At the location of the first stub, the allowed normal admittances can be found on an auxiliary circle, which is obtained by locating the unique conductance circle clockwise by an angle. What does this mean? Suppose let us consider the first easy case. Here assume there are no stubs, whatever. Z0, Zn. Okay. This we had seen. Now, so obviously Z0 is located somewhere on the Smith chart. The Z, normalized ZL. ZL is located somewhere on the Smith chart. Right? Question is how to find ZL. There are no stubs anywhere. Just think. How to find ZL? Remember that big formula we had, that Zn equal to Z0 ZL plus J Z0 tan beta L by Z0 plus J ZL tan beta L. We derived this. We had derived this formula in the class, remember? So that is one way of finding Zn. But if we don't want to go into, we have to use the Smith chart. How to find Zn? We did it in the lab, I think. What we were doing? If we move if we move along the load then we are moving clockwise. Sorry, if we move you remember this experiment? See, if set the load point 1, okay, this way I think is the best. This is not the best. What we are doing, what we are doing, very easily. This was my line. Okay, this is my load ZL. This is Z0. Here is the first stub. Here is the second stub. Obviously, a distance between the two stubs is this stub 2 minus this stub 1. Is it okay? The distance between the two stubs is this stub 2 minus this stub 1. This is load point 1. Just say this load point. So distance between the two load points would be this stub 2 minus this stub 1. Is it okay? Is it okay? Right? Now see here. So we are moving a distance of this stub 2 minus this stub 1 along the line towards the generator or away from the load. Is it okay? We are moving a distance of this stub 2 minus this stub 1 along the line towards the generator or away from the load. This is fine, right? And how does it represent? It's represented on the Smith chart. See here, this way. If we move along the line towards the generator or away from the load, we are moving in the clockwise direction. Since we are moving away from the load on a transmission line, we are moving in the clockwise direction. Correct? As we just told. Okay. So, and second thing, we desired that after moving this exactly this stub 2 minus this stub 1, this T12, after moving this distance along the line, okay, then we will reach the blue circle. Is it okay? After moving this distance, we reach the load point 2, where and the admittance must lie on the blue circle. Agree or not? So at load point 1, where we should be there? Where we should be? On the orange circle. If we are anywhere on the orange circle, after moving this pink distance, we will reach the blue circle. Is it okay? Let me write it for you. Oh wow. Is this okay? Do you agree with this? What I have written? If we are on the orange circle, after moving this distance d12 along the line towards the generator or away from the load, we reach the blue circle. Okay. For example, just 1 second. Stop it. If we are here, we reach here. This one, this one. If we are 2, we reach 2. If we are say 3, we reach 3. Is it okay? Right? Okay. So let me take the attendance and we'll continue in the next session.